1128 number of equivalent domino pair. Given a list of dominoes I is equal to a comma b is equivalent to domino j is equal to c comma d if and only if either a is equal to c and b is equal to d, or a is equal to d or b is equal to c. That is, one domino can be rotated to be equal to another domino. Okay, and we need to return such number of pairs. So let's take example 1. Okay, cool. So here we had given a 4 set of pairs. First pair is 1 comma 2, second is 2 comma 1, third is 3 comma 4, and fifth is 5 comma 6. Cool. So the given problem statement, we can identify that the pair 0 and 1 are equal because this 1 is matching with the last bit of 1 and this 2 is matching with the first bit. Cool. So that's it with this test case. So our answer should be 1. Cool. Let's take second example over here. So in this case, this we can easily can see this this pair and this pair are equivalent, and also this pair, right? So now 3 pair are equivalent, so 3 pairs, and so we can easily consider 3 into 3 minus 1 divided by 2, so that will sum up to 3 pair, right? So this 3 pairs will make 3 pairs where a is equal to c, or a is equal to d, and something sort of the given condition. So in this example our answer should be 3. Correct? Yeah. So that's pretty much it, and the constraint are given as 4 into 10 to the power 4, and our dominoes length will be equal to 2 in all the such cases, and the values in the dominoes are from 1 to 9. Cool. Great. So we need to go through each and every pair and check whether they are matching or not. That's a simple brute force which we can think about it. So let's try to write the pseudo code first. Okay, cool. So we had given a n number of pairs. So what we'll do, we'll iterate through all the pairs. Okay, and the second will traverse from I plus 1 to n. Cool. And now here I'll get pair I comma j, and for this what I'm gonna do, I'll check for same. Oh, okay. And also I'll check for alternative. Cool. And if any of this will match, what I'll do, I'll increment my counter, and I'll simply return my counter. That's it. So that's a pseudo code for it, and I feel this space complexity will be order of 1, but the time complexity will nearly order of n square, because we are traversing entire array 2 times, and it's a nested for loop, right? Cool. But okay, I tried it, but it's giving me a TLE for a larger input. So this is the pseudo code, number of equivalent dominoes pair, and we'll run a 2 for loop, and we'll check for the same and check for the alternate opposite as well. Okay, and we'll return the counter. Okay, now the problem here is we are traversing the entire array in the nested for loop, and that's why it's give us a TLE. How can we improve this? At the end of the question, we need just the pairs to be equal, and how can we check that? Okay, here we can use the concept of composite key. Okay, let's say if I am given a comma b, okay, and okay, I'll, for a safer side, I'll write a a0 and b0, and if I make a composite key c1, and it's the same for a comma 1 and b comma 1, and if I make the composite key out of this, and if my c1 is equal to c2, I can say these two are my what you say, equivalent domino pair, right? So we need to think about that function. So at first we can simply say that, okay, the simple composite key we can make it where the element is present will multiply it by the 10, or if it is at the 0th position, we'll multiply it by 1. So what I'm trying to say is, for my c1 will equal to a0 into 10 plus b0, and same for my c2, a1 into 10 plus b1. This will serve the purpose for the check for same, but it will not serve the purpose for alternative. Okay, so for this, either we can do the reverse way as well, right? But if I do the reverse way, like b0 into 10 plus a0, then it will serve the purpose for alternative, not for the same. Cool. So whatever, so we need to think, okay, how can we modify our composite function which will give us a c1 and c2? How can we do this? So the simple thing is, okay, whatever the my maximum slash minimum element, I'll multiply it by 10, and whatever my other element left, I do not multiply it with any other thing. That is one thing which we can do, right? So what I'm trying to say over here is, I'll define my c1 as maximum of a0 comma b0 into 10 plus minimum of a0 comma b0, and the same way for the c2. Correct. And what I'll do, I'll at the end, I'll store all this. Okay. Okay, so so that is also one thing which we can do over here, right? Rather than just doing the function call for each and every pair. But in that way also it will give a TLA, because we are traversing the array 2 times. So how can we uh, improve that? So okay, so our space complexity is order of 1. We need to like increase that by, like, we'll use some kind of data structure will which will store our composite key for the pair, and at the end we'll check for the pair. Okay, let's say c1 is matching, like how many count of c1 we had received, and then the simple formulation of pairs n into n minus 1 divided by 2. That's how we can just simply compute our uh, domino pair. Okay, so I'll go through the code once. Cool. So here what I had done, I taken a data structure as our map to store the composite key. So for each domino, I'll take the maximum element and the minimum element, and I'll form a composite key, and that composite key I'll storing into the map, and at the end I'll just do the mathematics of n into n minus 1 divided by 2, and I'll result the I'll return the result here, and this will pass by a flying color, as you can see. Okay, cool. Thank you.